an independent contractor. I'm working for some healthcare companies. Today I will talk about functional programming with Elm. And during the roundtable introduction, several people showed interest about functional programming, especially in the JavaScript. But I will show you, when you start to learn Elm, you will love it. You will forget about JavaScript, because Elm can transpile to JavaScript. So today I will talk about language, just the beginning level introduction of the language, then do some exercise, then share a little bit about my experience, because last week I went to the Strange Loop conference and Elm conference. So it's very interesting, so I'm going to share a little bit about that. So Elm language is very, very simple, because designer try to make it beginner friendly. In functional programming language, per se, we say everything is the expression. So we can see the values about. So we can have like a Boolean value, true or false. That's all value. Now we can have numbers. The number can be integer or float. So 3.14 is float, but we can use a number, lowercase number, to indicate it's an integer or float. Now we can have like char, character, we can have string. Now we can combine them together using mathematical way. So everything is expression. Just think about you are high school student. You are learning the math. No assignment, no for loop, no if, no undefined. But we have if expression. So if we want to make some logical comparison, we want to make some decisions, we can use if. So if expression, that's a Boolean value. So true or false. If it's true, now we return then expression. Otherwise, we return else expression. So there's a 3 expression in the if expressions. But if we have multiple branch, how we do that? We have if, else, if, else. That's pretty straightforward. Similar to other language like Java or C. But we have let expression. This is a little bit interesting. So if you have an expression, it's too big, you want to express lots of things, it's become like harder to read, understand. You can use let expression to break down, to break all the big one into small pieces, then combine those pieces together in the in expression. So for example, here we have we use called deconstructor way the language to deconstruct the tuples. Assign 3 to a name 3, 4 to a name 4, and hypotenuse is a function with AB and square, like a square. So then we have the whole expression is just this, to call another function inside let, then pass 3 and 4. So we can evaluate this very simple expression to break down using some meaningful name to express my ideas. That's the let expression. It's kind of new in the different from the other language. Now we also have case and pattern match. So the case expression is more interesting. Case expression, then based on the value of the expression, we can have a pattern match to match value then in different branch. So if n is 0, then we return 1. If it's 1, we also return 1. For anything else, if underscore means anything else, we return fib n minus 1 plus fib n minus 2. That's Fibonacci sequence or Fibonacci values. And for maybe, if it's maybe, then we can be just or nothing. So I will talk about this type and maybe type next time. So today we focus on functions. So what is function? Forget about all those procedures or you learn through C or Java, whatever. Think about function, just math. You learn when you are in high school. It's just math. You have some parameters, then you have expression to give that how we calculate, get the result of this function. So like square means n power 2, the square. Hypotenuse means square root square A plus square 2. So it's just math expression. So function is so easy if you forget everything you learn as a professional developer and back to the high school. But it becomes more interesting because if that's a lot that simple, it's not very powerful. But if we think about the recursive function, we will see the power of this functional programming. So here is the expression about Fibonacci numbers. You see, we try to calculate Fibonacci number. In math, we know it's just like a Fibonacci n-1 plus n-2, right? This is a definition. So if n equals 0, then the result is 0. If 1, result is 1. For all others, it's the previous two numbers add together. So we use this expression to express my functions. We don't need to do any of the sequence or statement, just expression. So you see, beautifully, we put everything together. Because this way is exactly the same as we express idea with math. So my main point here is the functional programming functions is just math expression. Now, next example is called repeat. So I want to repeat a number. I want to repeat something several times and give me a list of something. So here we say we have a repeat function. The first parameter is how many times I want to repeat. The second is what we want to repeat. The result is a list of something, a result, repeat these things. So how can we do that? The way we do that, if you think about procedurally or imperatively, we just say, okay, we just put 1 using for loop to do n times put together. But if we think about functional way, we have to think about recursively. We think about ways to build this function expressions. We want to use the same function, but with less, the input is kind of 1 less. The n is 1 less. So this is very crucial in the recursive functions when we design, when we build as function expressions. So we just, first of all, we check the edge cases. If n is less than or equal to 0, that means it's the dramatically or extreme cases. If 0, if 0, that means this list is empty list. I just return empty list. If not, then we can combine this result with the something we want to build, x, to append, to combine with the repeat same function to call, but with n-1 and x. So that's a recursive function call means. So we build the function with ourselves. When we say the function become expression and value, so that means this language is called first order. But if we can pass the function around as the input parameter to another function, or we return a function as output, we call this high order functions. So typical example is in the list module we have filter and map. It's because the
screen, so this is not you.
Okay.
It's being recorded.
Okay, no problem. Or just a projector problem.
Yeah, it's just a projector.
Okay, so I want to emphasize on the filter and the map function. There's two very important functions in the list module. But if you are familiar with the MapReduce or some other reactive JavaScript, you will pretty much understand what it means. So filter means I have a function which is take something, then return true or false, a Boolean. Then I have a list of something, then I return another list of something. So what's the result? That means I check everyone in the list of the input, list A, then use this function to filter out. If apply this thing A to the function return true, I will put that into the return list. If false, I'll just discard away. So that's a filter. So it's pretty easy to understand. It just filter out, right? And map is also very important and very interesting. So I have a list of something. I have a function from A to B. Then return is the list of B. I mean, I have a list of A, something like integer, list of integer. Then the function is to map something to another type or even same type, but it's mapped, changed, or transformed. Then result is all the transformed list. So here's the example. I have like a list input is the 1 to 6. That's a sequential number. The filter is I need to get a number greater than 3. The result is give me the number like 4, 5, 6, greater than 3. So that's the filter. And that's the map is the same. I have a sequential number 1 to 6. Now I double it. I use a map to double it. The result is 2, 4, 6, 8, 10, 12. It's just double the number. And be careful about in Elm, we say Elm is the pure functional language. So everything is immutable. When we...
Can you explain a little bit more about the lowercase types? Like the A's and B's?
Yeah, that's the Elm static a strong type system. So lowercase a, if anything I see the lowercase, that means it's the called type parameter. It can be any type. So it's not specified particular type, but it's just like generic. If you are familiar with Java, the generic is pretty similar, generic. But if it's a Boolean, like a capital case, that means they are custom type. So in Elm, we call custom type, or maybe it's a type alias. So I think I will talk about the type system about Elm next talk. Today I'll just focus on the function. So you can ignore that if you don't understand, but I think that's a little bit pretty straightforward. Oops. Okay, let's do some exercise because the best way to learn language is to practice, to do something. So let's give some exercise, very, very simple, like a high school or even elementary school exercise called combinations. So I have a list of something like ABC character. I want to have a function to generate all the combinations of a list. So for example, combination 2, now with the list of ABC, you should have a list of the list with each element of the list is the 2-element list. Just pick, that means we pick 2 elements from the list to get the combinations. So ABC's 2 combination is AB, AC, and BC. So if you look at the function signature, it's pretty simple. We have an integer, that means how many items I want to pick from the list. Now we have a list of something. Then I return a list of list. It means all the combination of those lists, right? This is like a very simple math problem. So the way before we use in the program, we have to figure out how we solve that problem in our mind. Okay.
This is recording, by the way, so
Yeah.
it'll be available later, if not now. Sorry.
So just using your imagination, I have 3 things, A, B, C. How can I get the combination of that? So the first way is I pick the first one, A. Imagine I pick the first one, A. Then I pick second one from the remaining part, B and C. I pick B. Okay, I got 1, right? 1 result, A and B. Now I put back B, now pick the next one, C. Now I got another result, A and C, right? Now I have to put down both and put down A and C. Then I move forward. I pick B out. Then I pick C, because I cannot go back, otherwise I duplicate. I go forward, now pick B, now pick C. So last way, we do these things, mental exercise in our mind. But how we express that idea in a program. Can we? Okay, anyone can think about that. during the previous examples, we say in the function programming, that's kind of two important things. One is the recursion. We want to use the same function to express ourselves. The trick is the combination of n number of elements can be generated by the combination of n minus 1 number of elements. Okay, that's not the. Okay, just wait for a second so we can show the hint. So, okay, so that's two fundamental mental switch when you do the function programming. One is using recursion, means combination of n numbers of elements can be generated from combination of n minus 1 elements. The second one is we have to look at the extreme edge cases first. In a traditional way, like when we are doing like Java or whatever, we always try to solve the happy path first. So make sure everything works perfectly with a perfect import, everything works. Now, oh, we are happy. We have to think about in the edge cases first, how we do that. So in the combinations, what do you think? Based on previous examples, what's your idea? So when we try to get the combinations of n with the list of integer or list of something. So let's say I have I use Ellie to demonstrate the practice, so that's very convenient. Let's say I have a program. I can make sure everything is running. They just display a list of the range, like a sequence 1, 2, 3, 4, 5, 6. So it sounds okay. Then I want to get the combinations above that list, like a 2 about the things 1 to 6. So to give empty because I haven't coded yet. Now what to do? So first of all, I want to look at extreme cases. If n less or equal than 0, what does it mean? So I have a list of something. I want to pick 0 number of items from that. So what's the result combination? It's empty, but actually it's a list with empty list. So this is a trick. You have to be very careful about that because mathematically it makes sense. You have a list of something, you pick 0 item from that. What's the result? Result is list of empty. Then else, that means if n is greater than 0, what to do? We said combination of n elements can be generated by a combination of n minus 1. So can be generated by combinations of n minus 1 and what's that? And list? No, it's not. We're missing something because we have to look at the list. So the list, it might be empty, right? So for list, we use the case. We use case expression, case list of if it's empty, what do? We return empty. So in this case, we return empty. Why? So mathematically, if we have an empty list, if nothing there, I want to pick something, there's nothing to pick. So result is empty, it's nothing. So that's the trick about that. But if there's something, so at least there's one thing in the head we call x. So that's the expression to break down the list in Elm. It's exactly the same as Haskell. If you're familiar with Haskell, you understand, very easy. But for others, it's just straightforward. For a list, you can break down into a head and a tail, x or xs. We use that to represent a list of head, a head of the list, a tail of the list. So if I got head of list, a tail, what do? We said we pick like A, right? It's head. Now what we do next? We combine this A with a combination of the remaining part, but with the n minus 1. Understand? So we combine that, that means using list called map, because we have a combinations n minus 1 excess. We have a combinations of minus 1 excess, the tail of this, but with less minus 1 element. Now we combine with what? With x. So we get the first one, A, and combine with the remaining one. So means in the map functions, result is I have like element. Then I combine this with x. So we hold the first one and combine with each result of the combinations minus 1 excess. Right? Does that work? So let's see if that works. It seems not. It's only one or two. What's going on? Anyone know what's going on? Forget about all the programming. Think about you are the high school student. You try to pick like 6 balls, like 1, 2, 3, 4, 5, 6. Pick 2 of all the things one. How you do that? You pick the first one, then you pick second one. You try to say, okay, I pick the first one. Then for the remaining 5 one, I want to get one of them as a combination of 1 of 5. But I forgot something. What's forgot? Means if I put down the first one, I still have remaining 5 ones. I can do some combinations. So I need to append all together. So this is only part of that. This is only kind of part of like I hold the first one, I get a combination. Then I need to append some other part. I mean, what's the other part? It's the combinations. Oh, sorry. With the n and excess. That means get rid of the first one, but for remaining like excess, there's a list. It's still a list. I can still pick n items from that, then get a combination, and I combine all together, last the combination for n and the list. Now I got all the result. That means 1, 2, like 1, 3, 1, 4, 1, 5, 1, 6. So last I hold 1, the first one. Now I put down the first one. I hold the second one, 2, 3, 2, 4, 2, 5, 2, 6. Now put down, I hold the third one, 3, 4, 3, 5, 3, 6. Put down 4, 5, 4, 6, and 5, 6. So that's correct. We can just say if I change to like 3. So I have 6 balls. I want to pick 3. What's the result? Yeah, it's the same. But if you think about imperatively in the procedure using for loop, also if I pick 2, I have to have like a nested 2 loop to do that. If 3, I have to have a 3 loop, but that's very hard when the system grows. By using the function programming, it becomes extremely simple because we combine these functions together and we express the function using self with the minus 1 and minus x and with the tail of the list. So that's the trick of this function programming. If you understand that, you will make it very powerful with a very simple, clean code. So that's one exercise. Another exercise, the 8 queen puzzles. I'm not sure how many time I have because it will take about 15 minutes to finish because 8 queen is a little bit complex. So do you guys want to continue or we skip that?
Do you want to do that one for part 2?
For part 2, I want to talk about type because this is pretty much similar. It's still same idea. You use the function, you use expression, and use itself to express yourself. I can talk about the question, then you can do exercise by yourself. So 8 queen puzzle is very famous. We have the chessboard about 8 by 8. Now we have 8 queens to put on this chessboard, and every queen should not like kill each other, right? So it cannot be the same row, same column, same diagonal positions. And the hint is recursively thinking. We try to place like a queen in k column. So suppose we already have the position figured out for the k minus 1 columns. Now we try to put a king in the k column to find the position. So that means we try to use the result of the king, k minus 1 columns king's position to build the k columns king's position. And the rule is a liu queen the row position cannot be equal to any of the previous king's position, queen's position, and they cannot have the same distance with the column and rows, because if you put a queen here, maybe put a queen here, they will have the same distance with this queen. So that means they are in a diagonal position, so they will kill each other. So that's the algorithm to do that. And if you try to solve that, I have all those things all figured out. And this is the code, but it's lots of fun to build that from scratch. So unfortunately, I don't have time to do that, but yeah, hopefully you can do some exercise by yourself. It's really fun. So before I finish, I will talk a little bit about my experience. And so last week I went to the Strange Loop conference. This is for developers, so it's fantastic conference. But this happening in the St. Louis, Missouri, and beautiful city. This is a very famous arc. They are like a landmark. So the conference in the Steefield Theater, yeah, huge theater. Very good, venue is good. But I want to talk about this M conference. I also attend called pre-conference, that's one-day conference before Strange Loop called M conference. So it's good. It's totally different experience when you watch the conference presentation through YouTube, or you go to the conference, you watch them talk in front of you. So I have a chance to talk to the guru of all this M language, this is Richard Fieldman, and this is the creator or designer of this M language, Evan. And my son got to see the creator of the language, and he's so excited. So one day's M conference, 9 talk, every talk is fantastic. It's very high quality. It's much better than previous years, in my opinions. And definitely I will watch again, because every talk is so good. So I highly recommend, if you want to learn M, find all those talks, even previous years M conference or M Europe conference. So that's my experience. That's good. So questions?
What I always wonder about with the Elm and function programming is, how do you actually use it to write a web app? If I have a form or something like that, how do you handle the forms?
I think before I did some presentation about the M architecture. Let's deal with how we do those web development. I want to just explain some ideas about this. When people talk about function programming, especially M is a pure function programming, you think about, for pure function, it can do nothing, because it's pure. That means for no side effect. So whatever comes, you always give the same result if the coming input is same, result is same. No side effect. I mean, they cannot print on the screen. They cannot call the HTTP server other side. It cannot do anything else. Means what point we use the pure functional language to build our web app? There's so many side effects we have to do. So the way M deal with it is called the M architecture. It means they have a runtime. So I don't have the slides here, but basically it's all the side effect is happened in the M runtime. It's a small, tiny JavaScript code to do all the command you give to them. So your program built by pure function language Elm, you don't exactly cause any side effect. You just send a command, say, I want this. You tell the runtime, what's my intention? What am I going to do? Then the runtime will get this command, will execute, do the thing, cause a side effect, then give you result as the message. So your pure function view will get the result, then render your program, render your UI based on the result because the model will be changed. So anyway, so that's another talk. I think I did that, but I may do again. But basically, for pure functional programming, all the side effect is happened in the runtime, and it becomes very small, concise, and bug-free, hopefully. Then you focus on your business. You don't need to worry about everything. You just send command, send command. Then you receive message, receive message. Then you react accordingly. So what happened? If that something happened, I got a message, then I change my UI, do something. If user click something, it becomes a command, then I push to runtime, then you do something else. So that's the main idea about this, the Elm architecture.
So would the whole form be a command, or like each key press is a form?
Pretty much every key press or link or button or something will fire the command. Then the update will handle that. Yeah. Okay.
So the language can interact with the DOM just like JavaScript, is that right?
Language cannot interact with DOM directly. They just send command. But they can do that through like a HTML module to indicate what I want the DOM look like. Then let's call virtual DOM to compare your DOM like built by HTML module with the real DOM in the browser to find the difference. Then very quickly to render inside the browser. So that's why even Elm language is functional. It's still performance is still very good because of virtual DOM. Okay.
Is the whole point of Elm, like from the folks who created it, to basically act as replacement for JavaScript in particular settings? Is that the whole point?
Elm was created just first of all as the events like his thesis in I think in Harvard, his undergraduate thesis for the functional reactive web programming. Then it becomes bigger and bigger. So I don't think they can replace JavaScript right now because JavaScript, this system is huge. But gradually, they try to make our developer life easier. So when we build application, we have so many problems to solve. We only want to focus on the business. We don't want to be distracted with all the other issues, like especially runtime errors. So for example, today I was assigned a super critical ticket. I have to resolve that within 24 hours because the system, client-side system, they have a non-pointer exception. The system crash. When user clicks some button, the system crash. So this kind of runtime error happen everywhere. But if you build your web application with Elm, they guarantee there's no runtime error. So I think even this worth a lot. Yeah, but I don't think they can replace JavaScript because they will transpire to JavaScript, right? Yeah, they will talk to JavaScript through port. Yeah. Okay.
Your examples focus a lot on recursive functions.
Mm-hmm.
I'm curious if there are computational performance or memory advantages using like recursive functions in Elm versus like in JavaScript.
Yeah. So function programming has a bad kind of reputation about this slow because of recursion. But with the modern compiler techniques, especially for tail recursion optimization, those recursive functions will become iterative function. So when the compiler, when it transpile into JavaScript or even to some other runtime bytecode, you will get rid of the recursive function using called like this optimization of techniques. So that's so many optimization technique used in the modern compilers in all the language. So function programming performance, I can say no less than C and or other like procedure language now. Okay.
What kind of access to JavaScript ecosystem do you have for for instance, TypeScript lets you import regular modules from.
Oh yeah. Yeah, that's a good question. So since Elm is pretty new, the ecosystem is still small. It cannot cover every case, especially for web API. There's lots of web API. They don't have a module to support it yet. So Elm provide this mechanism called port. Means you can invoke your JavaScript function through a port, but you cannot do that directly. You look at this JavaScript library or JavaScript toolkit as a remote service. You use a port to send a command to that. Then you receive result asynchronously. So that's the trick. So asynchronously. Some people have some issues with that, but we don't want to talk about it right now. So currently that's the only way you can communicate with the third-party JavaScript libraries.
All right, let's thank our speaker.
Okay, thank you. By the way, if you are interested about Elm language, we can talk about after session because it depends how many people interested. So maybe we can set up the local Elm meetup instead of I always steal the time from Nixon.